Hello, everybody. We are live. Welcome to the 2025 Summer of Protocols Guest Talk Series, a weekly event where we explore the frontier of protocol studies with industry experts, founders, researchers, and other brilliant minds, such as today's guest, who is Peter Wang, the co-founder of Anaconda, and who currently leads their AI business. He also recently announced SkySeed, a venture fund aimed at supporting work on the Blue Sky AT protocol. And today he and Venkat will be talking about what he's up to, and as well as his topic, which is AI as the anti-product. We have an excellent slate of guest speakers coming up. Next week, Venkatesh Rao, the program director, will be talking about some things from sci-fi to the upcoming program, maybe some other things if you're lucky. On April 9th, program alumni Nadia Asparova and author of Building a Public will be talking about her upcoming book on anti-memetics in a fireside chat. April 16th, we have Saram Kannan, the founder and CEO of Eigenlayer. And on April 30th, the former CEO of Twitch and former interim CEO for a day of OpenAI, Emmett Shear. So without further ado, I'll bring on the speakers for today.
All right. Hey, Peter.
Hi. So we meet again. This is fantastic. I cannot tell you how excited I am to have this conversation and how honored I am to be invited onto the program.
Yeah, it's amazing to be able to do this. Like first conversation we had in person actually just a few months ago, even though we've kind of like known each other online for, I guess, a decade or something. That was a lot of fun. Like I don't think I've just gotten into it for like a 3-hour long conversation since grad school. So that was fun. So yeah, great to have Peter on the town hall. And for those of you who aren't familiar with Peter's background, if you're online on Blue Sky, he's very active there, and he used to be on various other social media as well. But Peter is best known as the founder of Anaconda, where he now leads the AI work. And Anaconda, for those of you who are not in the engineering world, is this development environment for scientific computing that's roughly kind of the open source competitor to MATLAB, I would say. That's one way to describe it. And my own background is in control theory, so I used MATLAB a lot. And I've tried using Anaconda a few times, but this was after I turned into a manager, so I didn't have the chops to do much with it. But yeah, Anaconda is like what is used all over the place as the place to do scientific computing, including increasingly AI, I believe. Like we should actually talk about that a little bit. Like I think low-level plumbing is actually very interesting to talk about. Like how do people actually use modern tools? So everybody's probably heard of things like PyTorch by now as the foundation of AI, but it's interesting to talk about how AI developers actually do things. But a couple of other interesting things about Peter. He was involved in the early stages of what became Blue Sky, and he's now trying to like get some action going there with a little fund to promote development on Blue Sky. So we'll talk about that. And maybe if we get a chance, we can talk for a few minutes about astronomy, because I think that's actually one of the topics where we started talking early on Facebook, I think. Like I saw you starting to build a huge, like 18-inch telescope. Is it 18 inches, I think?
28.
28, sorry, yeah, much bigger.
No, so the real flex at that point, you start using the units of meters. It's a 0.75 meter telescope.
That's like a level of, I don't know, it's the humble bragging threshold of, all right, now you're in with the, Mount Wilsons of the
Now it's real stuff. Yeah.
Yeah, so that'll be kind of interesting to actually try and tie into conversations, because I'm an avid amateur astronomer myself, though I only have like a 4.5-inch telescope, and I live in terrible areas where it's hard to ever use it. But yeah, so lots of interesting places we could go. But yeah, Peter, why don't we start with kind of like, you have this topic on your mind of AI as the anti-product, but maybe we can start with kind of like just where's your head at these days? Like, what are you thinking about? What are you dabbling in? What all is going on?
I'm a man about town nowadays, and so I think The interesting thing is, yes, I have a full-time job at Anaconda still as the founder and founding CTO, CEO for a little while, and now Chief AI Officer. I spend my time at Anaconda thinking and working on, everything from our product strategy and next generation products to looking at the open source ecosystem. And now I should say ecosystems. And this might be something we get to talk about today, which is the open source ecosystem around Python, as well as the open source, well, not even open source, but the technical ecosystem around AI, right? And so, a lot of businesses go through this kind of evolution where there's a first horizon and there's like Act 2, Act 3, so on and so forth. And I think around the data science business, the numerical computing business, and all the stuff that we unleashed when we founded PyData and Anaconda and all these things, that open source disruption of numerical computing, to your MATLAB point, all of that stuff happened over the last 10, 12 years. But now we're looking at, okay, that also laid the groundwork, right? The Paul Simon's quote, "Every man's ceiling is someone else's floor," or something like that. So now that all of that infrastructure becomes the technical substrate for the AI explosion. And the AI explosion, of course, is bringing a lot more people into the mix, not just numerical computing people or people who know what vector computing means, right? Mm-hmm. So I work at the intersection of all of that during my day job. And we've had, as a business, we've grown quite a bit, had a lot of new executives and leaders come in, all really, really fantastic and interesting growth. And as a business, as a founder, going through that entrepreneurial journey has been really interesting for me. I realized I have a very unique perspective because I come from a scientific background, ended up in the software business as a consultant, ended up as a software founder, and then have had to deal with both corporate customers as well as corporate users, then as well as the capital markets and investors. And then now, with the blue sky stuff popping off and the atmosphere, the app protocol ecosystem, I find myself as an investor, an advisor in that ecosystem as well, and somewhat of a community steward. I try to be a good steward in that way. So running as a through line through all of these diverse things, it even connects to astronomy a little bit, but running as a through line through all of these, there is fundamentally, my background is as a physicist. So I have an orientation towards trying to scrub away all of the excess stuff and get to what is the heart of the issue. I'm always looking for the root fundamental things. And then a deep curiosity and a bit of ambition or conceit, however you want to code it, that I can follow that. I will follow that white rabbit. I'm going to find the right white rabbit and follow that white rabbit all the way through. And that's led to my business and entrepreneurial successes, but it's also led me through different phases of technology ecosystems. So seeing both the technical realities and possibilities, seeing the human ecologies at different phases of maturity, and then seeing how the existing structures, the system of the world, both in the corporate world and a little bit in the policy and government world, as well as in the financial capital markets, how all of these perceive these kinds of changes in human ecologies. And all of it, that through line, I think, is the thing to talk about and maybe to center on today, which is when complexity meets complications, when complexity and the liminal or the estuarial sort of waters between emerging infinite possibility space and organizational and human approaches, technical approaches to managing complexity by rendering them as mere complications. And that, of course, connects to your work with contraptions and many of the thing I first came to know you for and love your writing for was the whole Gervais theory thing, which was, as I was going through my consultancy, watching disruptive innovation land in a corporate structure that could make no sense of it. That was just a really brilliant work that I really appreciated. So anyway, that'll be the sort of the opening act here and laying out kind of framework of things we can talk about. It doesn't have to just be AI, but I do think AI is a very interesting thing to center on as another way of how people and organizations can interface with and comprehend complexity.
There's a bunch of interesting threads we could pick up on, but I think the one that immediately jumps out at me is your complexity versus complication point, and focusing in on particularly on, I would say, almost the developer experience of computing technology in general, not just AI computing. If you look at the developer experience, like one of the things that strikes me is if you look at things like Anaconda or MATLAB or the Eclipse IDE, we are used to like tooling that was like large and complex, and then deployment pipelines that plugged in the individual developer into work groups, and then large organizations that are running like data center scale software. And there's a couple of dimensions of like complexity and complication along that path. Like one that I think everybody's talking about these days is, on one front, it looks like the complexity is just falling apart, and you've got this idea of vibe coding, where it's like literally you just tell the computer to do something and plug the error messages back in, and it's sort of like cycles. And Steve Yegi just wrote a really awesome long essay about
what Steve Yegi wrote a long essay? No.
Oh yeah. He's one of the few guys whose long essays I don't mind reading at all. I don't even like reading my own long essays, but Steve Yegi I'll read. But yeah, so vibe coding is one dimension. I don't know if you would call that complexity or apparent simplification or something. So that's one direction. Another is you've got like, individual star AI programmers like Andre Karpathy or others who kind of like are on Twitter, live streaming like really awesome superhero stunts, like making up their own LLMs from scratch, things like that. But then you talk to people at the big AI companies training the huge models, and they're talking about like, how do you like get a model training going on like 10,000 chips? So there's like that vector of complexity, right? And on the other extreme, you've got open weight models like Llama that people try to run on Raspberry Pi scale. And the final vector, since we to connect up to blue sky potentially, is how do you then start like connecting the tooling to distributed environments. And I want to mention here, Kevin Kelly just wrote yet another, he's 73, but he's still at it. He wrote this visionary essay called Public AI, where he envisions like a network of like open source public AIs that are federated and can talk to each other like Blue Sky, which is a big theme in the program this year. We are really trying to help think about protocols for distributed AI. But yeah, so why don't we start by talking about like the contours of complexity and complications in developer tooling across these things. So I know it's a large canvas.
Oh, that's great. Yeah, I mean, the great thing about orthotic space is it doesn't matter where you start, you end up going through all of it. So let's just do it. So I think maybe we should level set for the listeners and the audience, really putting a strong line between complicated and complex. And those, like you and I and people who, are steeped in the Santa Fe Institute kind of stuff, this is natural. But for a lot of people, I would say these are probably actually synonyms. If you go and ask a random person on the street, hey, it's a complicated thing, it's a complex thing, whatever, it's all the same. But we use those terms very, very precisely. And there's an ocean of difference between complicated mechanisms and complications versus complexity and chaos and substrates in which emergence is possible. Okay. And the most accessible way to talk about this is that a 747, a Boeing 747 jet aircraft is complicated. It is very, very complicated. No single person knows how the whole thing works. It's got subsystems that are managed by entire teams. But the cool thing about a 747 is that humans can take it apart and put it back together again. So it's complicated, but it is reducible into smaller pieces, which then have boundaries and conditions and performance criteria. And we can put these together in some linear or pseudo-linear fashion. So when a pilot pulls on this thing, this other thing moves. And I'll have to send you a picture. I was just at the Museum of Flight in Seattle, and they have a 747, the first one, the test prototype one, completely open. And you could see the cables and the pulleys that run across the thing and go up into the control stick. It was still a mechanical system. So a 747 is complicated. A complex system is a cockroach or a frog. Much smaller than a 747, doesn't do as much as a 747, but nobody on the planet can take apart a cockroach and put it back together again in functioning order. So this is the difference. When we say financial markets are complex, what we mean is that there is emergent patterns that cause things to happen. Every cell inside the cockroach, it could be argued, is actually complex. There are a lot of higher order dynamics. We don't really know the field of epigenetics is just really kind of emerging, and we'll get more knowledge as time goes on. But just the story of DNA encodes protein factories, and they make these things. No. That's a very like biology 101 view of the world. The actual thing that happens inside a single cell, inside a little cockroach, is a lot of emergent complex dynamics. So there's a tremendous, we live in a time, one could say at the trailing edge of an era of modernity and a certain secular religiosity about the fact that if we can have an analytical forward model, a mathematical model, there's people who look like they have serious degrees talking about things that they know what they're talking about. All of the dressings and the Pope hats and all these various things, the theater of a ivory tower of scientific arcanum gives us a sense of comfort as middle-class sense makers who don't really understand any of it, that people, adults who know what they're doing are on top of this stuff. But actually the reality is every scientist, an honest scientist would tell you, we don't know how any of this works. Right? You talk about, let's go back to MATLAB. Every engineer who goes into actual engineering knows that you take these big, beautiful physics theories, and you turn them into ODEs and PDEs, right? Differential equations, and then you make linearity and simplifications and reductions, and then you solve for something within a linear regime. So you put this much energy in, you get that much power coming out. Or you turn the thing this way and then the thing moves that way. Like we impose this kind of general linearity condition on everything, and we do it in the managerial sciences, right? The O in OKR is operational, right? If something is, if you turn left on the steering wheel and the engine explodes half the time, that's not an operational vehicle, right? With an organization, if you say, we want to go 10% faster and the whole thing explodes, you're not operating very well. So in the world that we have today, the world of modernity, everywhere, once you know to look for this, you can see it everywhere, that we take a complex and emergent and a dynamic world, and we impose through the mechanism of science a particular perspective to do sense making on it as if it were linear, as if it were a simple input, black box, output kind of a device. And so vibe coding then, the topic you asked me about to start with, let's now proceed with vibe coding with this perspective. That I think the way you approach it depends on how you perceive what the coding activity is. And I'd say that there are three different approaches to coding. There's a craftsman approach, which I would say a traditional programmer who came up in the 90s or whatever, like, oh yeah, I've got a VM, I've got a language, syntax, there's libraries. You're sort of crafting some stuff, and you know that there could be processes that make you more efficient and make your team more reproducible in terms of delivering features per sprint, et cetera. Story points, whatever approach you want to use. Okay, so that's a craftsman sort of, let's say, almost a medieval era approach to craftsmanship. And then there's a managerial approach, which comes in with Taylorism and the Ford, like factory reproducible pieces. This is really the Industrial Revolution, is the application of energy to making reproducible pieces and then bolting the pieces together. Again, linearity, simple decomposability, and simple modularity and composability. So the managerial approach then views coding as this kind of somewhat gnarly activity, but it can be managed. It is a merely complicated thing, and we can build complications around this to turn your contraptions into something much more reproducible. Now with vibe coding, what we have is a religious approach. It is prayer. It is like when you go to Tibet and you see all the little people writing prayers on little scripts and they hang them. When you vibe code, you're putting prompts on the script and you're, ringing a bell and you're hoping that it produces, farts out some code that actually runs. And if it doesn't, you get another prayer script and you write another thing on it and you hope that, try again tomorrow. So these three approaches towards the coding activity, these three perspectives on the coding activity are, I think, they are tied to, and they're directly connected to how one perceives the complication of a computer and of the information systems we interface with. Is it a means to an end? Is it the ends itself? Or is it substrate for something else? So.
Okay, this is a very high branching factor conversation, as I remember our Austin in-person conversation being. So let me pick on one thread that interests me. So in your three-part scheme of going from like craft to industrial to sort of like a religious prayer, I think I would put Anaconda in the middle, and I think the determinant criterion is actually the use of things like package managers. Like I think looking back on my own history with programming, one of the reasons I got really good at MATLAB is you really don't have to think about setting up your dev environment. Yeah, we've all seen that meme of like, I just have to set up my dev environment and it falls apart. And looking back on my own journey away from being a hands-on engineer and programmer, actually, I think after I left Xerox or in 2011, and I was like, I'm not going to be programming in MATLAB anymore if I do technical work. And I started thinking about, should I switch to Python? And then for a year, several years, I was caught in the 2.0, 3.0 fork crisis that Python went through. But I think the thing that finally made me decide this is not the style I can really get into was the amount of environment management that modern programming seemed to increasingly require, right? You have to manage like operating system environments, versions of like containers, versions of packages. You've got like, even in Python, there's like 3 or 4 ways to manage packages within like your Python development, right? You've got
people are praying for 3 and 4. Venkat, it is at least a dozen, if not more.
At least a dozen. That shows you how
a dozen primitives and then hybrids of them, right? Yeah, there's a dozen
ways to put these factories together, right? And if I try to sort of like now look at AI, and this is just the, I would say, just above the middle layer of the stack, right? You go dig a little below, you've got like the CUDA layers that are like an arcane mess. You've got like OpenAI trying to produce Triton, which is a slight cleanup of the CUDA mess. You've got people like over at DeepSeek diving deep down into the PTX threads level. So you've got like this almost Jenga tower of like layers of crap of varying degrees of openness and complication and complexity. And I would say the tool chain is still in the complicated Boeing 747 corner of the Kinefin diagram, perhaps is the map we should use. But yeah, the tooling is still complicated, but increasingly the output, the stuff that comes out of the tooling is not complicated, but complex. So AI models, trained models, they're complex emergent things, and AI programmers are somewhat of a hybrid between what we used to call data scientists and like a traditional craft or factory programmers. And they're doing this some sort of like black magic-y thing. And suddenly out the other end, you get like a trained model that statistically behaves in like weird emergent ways, right? So would you agree with this overall characterization of where we are?
I would agree with it. Let's see. For the purpose of this conversation, let's pretend that I agree with pretty much all of it. I do think I agree with it, but I think there's a lot of asterisks, and you're absolutely right. The branching factor is extremely high on this. But you know, there was a well, let's see how to tackle this. I'll go chronologically in sequence, responding to kind of the things you touched upon, right? The reason why with MATLAB, and it's really fascinating because most people talk to me are people who have chosen Python, right? That's why they end up in conversation. There's sort of a Bayesian prior on this, but to have a conversation with someone who chose not to use it because it was just too damn complicated, that's fantastic. That's actually really fantastic, right? Because I think people who are in Python land can oftentimes have quite a bit of a bubble, like an echo chamber around how great everything is in the tooling. It's like, no, actually, this open source ecosystem we have is really kind of a mess. Andreessen had that great quote about software eating the world. And the reason why software can eat the world is because it's so much better than paper and pencil. But let's not kid ourselves that we're doing anything right here, right? That for as long as I've been reading Steve Yeggie's long posts, but really for even longer than that, we have been in the software industry, people in the 90s, maybe early 2000s, were talking about how it is like architecture before the discovery of the arch. It is just really stacking stones. And whereas scientists advance by standing on each other's shoulders, computer scientists advance by stepping on each other's toes. So we just the ability. And I think it should be taken both in jest, but also as a point of seriousness. The ability to basically remember anything forever with basically just electricity. I shine a light on a bit of glass, my solar cell. I plug it into a Raspberry Pi, and now I can remember something forever. That's really pretty freaking incredible, right? And so the ability to have infinite memory, essentially, relative to the kinds of tasks that humans and human organizations need to achieve, the ability to instantly transport information, ideas, and context across the entire ocean. Again, coming back from the Museum of Flight, you realize those first airplanes, they were delivering mail, right? The first telegraphs were telegraph lines to coordinate trains arriving, because electricity runs faster than a steam locomotive. You can get the information there about, hey, a train's going to be coming in about 45 minutes. But all of these things that were massive amounts of infrastructure to build, now we don't even think about them. The idea of running fiber optic cables in the bottom of the freaking ocean, whatever. It's just like, of course you have one of those. So we just have this incredible, the fact that GPS maps works at all is because of the ability to do incredibly precise time tracking with devices, that are smaller than the deck of cards. Really, the GPS chips are smaller than the deck of cards. And you have a satellite constellation hundreds of miles in the air, moving with extremely precisely calibrated motions around a dynamic and complex gravitational environment around the Earth. The sheer amount of substrate that we sit on top of. And then we write a bit of crappy Python code and say, well, software's eating the world. Well, no, it's not. The technical infrastructure that has been built over hundreds of years, the science and the physics and all that stuff, that created all of these things. And then you write a couple of crappy Python scripts, you aggregate a few million eyeballs, and now you've got some really good ARR to show the investors, right? So I think it's really, really important to understand that the perspectives coming from the software industry are themselves a microcosm and just a very narrow slice of the overall revolution that humanity has been going through. Now, the reason I go into all of that is because we're talking about AI and AI's disruptive capabilities. Really, the issue here is that on top of all of these are still all complicated mechanisms. And when we write software, the reason why Python took off, the reason why I started the business, is because I recognized that in the 2000s, the aughts, 2000, 2010 timeframe, I was doing a lot of consulting around scientific computing with Python. And we were getting pulled into places where you would expect people were, not getting what they needed out of MATLAB, or they didn't want to write Fortran and C++ anymore. They wanted to wrap it with Python. And it was very much a self-service thing where this is really important, non-programmers, non-computer scientists, non-software engineers, right? An entirely ignored class of white-collar workers, knowledge workers, smart people. They were picking up a free and open source tool because it was free and open source. They could take it and they would start using it to solve their own problems. And then we started seeing this happening now you could say, well, scientists don't have a lot of money, so of course they'll use free things, right? And MATLAB is expensive and all that. So fine. But then when you go into investment banks and you go into hedge funds who have more money than God, and they're pulling these same tools, then you're like, wait, hold on a second. Maybe there's an opportunity here, right? And you realize actually the important thing here is that the technology of writing numerical code and running simulations and numerical algorithms at scale, that was deeply empowering for an entire class of users that have been left behind by the business computing, enterprise, Java, blah, blah, blah kind of software development approach of the 90s and 2000s. And so that was the opportunity space that Python landed itself into. A lot of people inside Python land actually don't even appreciate this. They thought it was like, we have to have an answer for Ruby on Rails. Otherwise, we won't be serving up websites and we'll be out of the back end. And me and my co-founder, Travis, who's the author of NumPy and SciPy, we saw there was a huge opportunity to serve an underserved community and an audience. And we did that. And then the rest is history. Then when we brought numerical and vector computing, array computing to the masses, what do they do with it? Well, they created machine learning workflows. They made a much more predictive world. And then they built AI tools, right? If every single one of those AI engineers had to go and learn how to debug a bunch of Fortran or C++, we would have much slower progress in that area, right? So the interesting thing is that we provided a tool that allowed a wide number of people to go and self-service and build, remix, share. And so that explosion of open source mess that I would say maybe sensibly turned away from, that's actually how we allowed the leaf nodes of the ecosystem to explore and do innovation and figure out the art of the possible. So to net all that out, I would say that these big, closed, well-defined kind of things, what they leave out at the edge, what do you hit when you hit the edge of the city? Well, you don't have ordered streets anymore, but you hit the forest. And what's in the forest? Well, everything's in the forest, right? So anyway.
Okay. So again, lots of tempting places to go, but I'm going to try and pick on a couple of directions here. Interestingly, I wouldn't call my personal trajectory a model to learn from. It's almost like a embarrassing thing people should not learn from. And I just remembered something, like when I joined Xerox in 2007, the first project I was assigned to was they had like this complex piece of software to do image quality analysis of like photocopiers. And this had been written in Python by a couple of physicists over the last decade, and it was like only a couple of physicists were using it because they were the only ones using Python at that time. And they were at that point bringing engineers like me on board to like do more production use of the image quality software. And one of them had recently ported the image quality analysis software from Python to MATLAB, and it had come on board. And I was like, all right, now I can use it. So I was doing for a few months, I was doing work, and I thought of myself as, all right, Python is this old obsolete language, and finally we're updating it into a modern thing that the rest of us can use. And so 2 years later, I was like, holy crap, how did I get that so backwards? I'm the opposite guy. I should have gone in exactly the other direction. But yeah, so you've got all this complex messiness, and that's, I guess, part of the price you pay for going open and democratized, and more people can use it for free, and more optionality means there are going to be more options that you have to navigate.
Unfettered innovation, I would say. And this is actually at the heart of some of the conversations here. Enclosure versus exclosure.
Yeah, and to your other point, a lot of this only affects the top couple of layers. Like you dig down, like CUDA is a completely proprietary thing, right? And that's right. One of the companies I work with, Tenstorrent, is trying to come up with like an open source alternative. Other people are as well. But the image I'm getting of this is you've got these layers of the stack, but understood as like historical geological layers. And the older layers are more mature. They're often more complicated and structured. Upper layers are kind of like crappy and cobbled together. But the whole edifice, I love the metaphor of like people throwing together monuments without knowing how to build arches and domes. That I think feels exactly right. And I want to bring in here the angle Andrej Karpathy introduced, I think, couple of years ago, where he talked about like software 1.0 versus software 2.0. So it feels like, software 2.0 is the top layers that are like both created with AI and are like in an AI paradigm almost. So vibe coding and stuff, both the product and the process. And I think a lot of people believe that even though it's now just the top layers, it can almost eat away at the lower geological layers, and eventually the whole edifice will get transformed into what you're calling like your third generation world of prayerful technology, which we could call it, right? Like you can imagine a future where software 2.0 has eaten everything all the way down to Verilog and like hardware definition stuff, and everything is like this vibe stack, right? Like old layers have become, and then you've got I want to introduce the sort of like next sort of like conversational theme here. So you've got this happening at the individual like dev stack, but you've also got like distributed systems coming in now, right? Like everybody now wants to ask, how do you get models to talk to each other? How do you get like development environments to talk to each other? Like Anaconda, I think, still reflects an individual programmer era. And increasingly, everything is about like you've got dozens of programmers across the world possibly collaborating through GitHub on the same code base. But in the future, it would be they're vibe coding on like the same, they're like, collective prayer, 100 monks praying together at the same time. Like you look at like, the new AI coding tools like Cursor, and I think Windsurf was one that's making the news. I wonder how programmers learning their, well, not craft or engineering, but prayer techniques now will collectively operate in the future. So yeah, can you like segue us into like how groups of programmers are now praying together, maybe is the way to think of it?
Yeah. This, I think something that would be right up your alley, and maybe people who are finding this part of the conversation interesting and not completely just crazy and out in left field. There was a fantastic podcast that Jordan Hall did with Jim Rutt right before Christmas, and it was on this idea that that basically for us as a society to encounter AI and to really handle it in a high fidelity and high integrity way, we need to recover the concept of a soul, and that to consider AI systems and the possibilities of what AI could be for humanity from merely the perspective of very individualized collectives of mere aggregates, we lose. Again, we take a complicated and complications and modernity approach and we see AI only as extensions of more complications. What we don't see it is that it's a way for us to engage in the complex, because we in the West in particular have lost the ability to think of ourselves actually as part of complex dynamics and ecosystems. We see ourselves as part of societies, not communities. We see ourselves engaging in tasks, not rituals, right? And so the idea that to actually manifest, well, no, for AI to be as impactful as it could be for us in a good way, for us to actually encounter and manage it to some extent, we need to actually approach it because it has the possibility to, I won't say embed a soul, but has an ability to extend the soul of a person or of a community. Therefore, when we approach it in a soulful way, we get more out of it. Fantastic blog post, or not blog, podcast. So anyway, with that perspective, now let's look at the thing you're talking about. And let's just go, let's speak of branching factors. We'll just blow up the Lyapunov coefficient here and just say, fuck it. So here's what we're going to do. Software 1.0 versus 2.0. I don't disagree with any of the things that like Karpathy says about this kind of stuff. I think it's absolutely the case in technology that when you have to take a path-dependent thing, you have to do some bad things, then you realize, oh, wait, hold on. This is actually the right way to deliver this new possibilities with how a larger group of users want to use it. And then you build the shortcut, right? So we have that, metaphor of paving the cow path. And frequently when we talk about that cow path is sort of like letting the collective wisdom find the shortest path. Where does it want to be? Sort of a kneeling kind of process. In this case, sometimes cow paths are meandering through the woods, and you realize that there's, as the crow flies, much shorter path you could have paved, right? So when we do innovation, when we do technical work, these are the kinds of things that we discover. So it is not surprising to me at all, given just how slaptastic most software systems and information systems are built together. It is not surprising at all that we might say, hey, we've got this thing where a business user or just a regular human, I call them muggles, a regular muggle who is not a wizard, can come in and say, I would like my food to be warmed up, please. And then it just goes and does the food warming thing, right? Or I would like a software system. I would like to present an application that lets me see what were the top reports from these databases. Were there any emails about these problems? Bring these together and connect them. And a normal person, a muggle, can state what they would like. And now we finally have the capability to some extent to auto-plumb and auto-connect all these backend pieces and write the YAMLs to spin up the Dockers to do the various things and auto-code some Python and do all this crap. So that's fantastic. That's fine. I think that will proceed in a very nice way. It will deliver hundreds of billions of dollars of market value to lots of companies that can seize on the opportunity. Fantastic. But it's still missing the question. It's still a managerial and I would say venture capital disruption way of looking at the world. Someone had a great quote. I think it was actually on Twitter the other day. That was put very, very concisely. If you tell me that you've delivered, a 5 or 10x improvement, okay, you're a genius. But if you delivered a 100x improvement, it's because you stopped doing something dumb, right? And if you look at how incredibly dumb most of the hoops we jump through are, in the software system, and not just individuals like you and I using, in a B2C environment using software systems, but in a B2B environment, I mean, if you actually have to sit there in your whatever 4 or 5 year old HP, Lenovo enterprise laptop, you're logging in, you get all this crap that you're churning through just to get anything done. And in those environments, that's why what we found is that, people go and they grab data because they need to have the data. Getting access to the data system can take months. So if you get some data, they get the data. And then can they install this software tool? Or what software tool IT let them install? Okay, well, we'll get that one. And then they put it together and they make something that basically works. And everyone else, they're like prisoners, like in the catacombs. They're like, wait, you have a thing that can do that? Wait, can you share it with me? Okay. And this kind of work, I mean, in the industry, it's called shadow IT, right? But when we get pulled in those early data science, Python data science days, we were pulled in as a preferred tool for this kind of a thing. And the end users and the lines of business would be adopting these things to tap into the capabilities that have been held out from them for a long time. So the point of all this is to say that a lot of VCs made a ton of money schlepping and selling and pumping a bunch of different kinds of enterprise software companies up there. But at the end of the day, it hasn't been about, and this is a term from the 80s, end user programming. It has not been about putting as much capability as possible into the hands of the people who know the work that needs to be done. And if you look at the old ads for the Apple II back in the 70s or whatever, they have a picture of an Apple II with the BASIC on it in the kitchen because the housewife in the kitchen was going to input basic code to manage her recipe file. So you want to talk about legacy futures, the concept that I love, that term. That's a legacy future we never manifested, right? So all of the complexity, all of the complication that can get squashed and reduced by AI absolutely can be there. But where can AI really take us? Where could it really go? Well, collective prayer, for those 100 monks to be programming or to be praying together, they need to be a tribe. There's got to be actually some soul there. Otherwise, it's just an aggregation of merely 100 individuals, right? And not a coherent sort of a thing. And this gets to then maybe the next part of the talk could be about, or this discussion could be about open versus closed protocols and protocols versus apps and all of that.
Yeah, that's exactly where I was thinking. Like when you said like 10x improvements probably means you're a genius and 100x probably means you stop doing something dumb. One of the most common ways to get that 100 by stopping doing something dumb is stop keeping things proprietary. Like a lot of people are unnecessarily like attached to proprietariness as kind of like some way to, I don't know, create wealth, and they're like really afraid of going open. But the moment you go open, you usually unleash like 100x things. So Python or MATLAB it would be an example at a lower level of abstraction. RISC-V versus x86 or ARM would be a thing. Like each time you go open, somehow you seem to open up like 100x thing, and instead of like 100 engineers in the belly of a large corporation doing this shadow IT anxious like configuring to do like some very limited thing, and then what comes out looks like a computer in a kitchen, you have like 100 people in a much more free and open sort of like system where they can organize in complex emergent ways and produce stuff that's like a lot more magical. So in a way, this whole soulful, prayerful thing, like I'm remembering somebody just mentioned, I think it was in a Substack newsletter, something like software is a mechanism, but software ecosystems are like organisms, something like that. And a lot of engineers, especially ones trained in the 80s, 90s, and aughts, we are too used to thinking of like software is a mechanism, but software ecosystems are also kind of like more complicated mechanisms. And I think one of the lessons of open source is once you move open source, the ecosystems are more like organic beings, and you can actually hurt them, harm them. You can like make them toxic. But if you bring the right kind of soulfulness to them, you can keep them healthy and thriving. And I think this is the big lesson of like open protocol stuff. Like a lot of things that managers do in factory software setting, which are kind of like complicated machine things, which are kind of like honestly a world we should and are leaving behind. In this world of like 100 programmer monks praying together in an open source temple in the forest. This is kind of the image I think you and I have built up over this conversation. So 100 open source programmer monks in the forest conjuring like emergent ecosystems together. So this is kind of like the picture. Now,
is there any way that I can share slides in this thing? I'll present, right?
Yeah.
Okay. So can I sort of, I'd love to, this is a perfect bridge. So I'll just run through really quick some slides I have from 2019. All right. That just slides and PDFs. Oh, add files from, oh shoot, your computer. So it's PDFs. Okay. So hold on. Let me go and find the PyCon DE 2019 keynote. PDF. There it is. Okay. Where is this in my folders? It is in this presentations folder. So I'll open that up and then I'm gonna go here, present. See, this is something that should be automated by an LM. Okay. Okay. Upload file. Come on. Where's the file upload? Okay. And then I can drag this into here. Great. Open. This will take, it's 30 meg file and it's uploading. It's getting there. So what I was talking about there is called rethinking open source in an era of cloud and machine learning. And in 2019, I had seen some dynamics and things that I was realizing, there's really like, we'd always talked about open source in the same way you're talking about, like, oh, openness unleashes all this like amazing energy that's latent. But what is it about open source? And is it sort of axiomatically true that opening things up and the proprietary is locking down value and opening makes it better? And I had very similar insight to what you just said. Now it's processing the slide. It is okay, but But what I came to was like, okay, you know what? What's interesting, what I observed was in the open source Python ecosystem, in the numerical computing part of it, it was different than the open source communities I've been in since the mid 90s with like Linux and X Windows and Apache and Emacs and Vim and all these things. So what was different was that the people who were contributing to the open source ecosystem in Python were these physicists who wrote the code that you ported to MATLAB. It was assistant professors, it was researchers, people who saw code as a means to an end, not an end unto itself. And they had to scratch their own itches because the CS nerds didn't know enough differential equations to write the code for them, right? So let's see here. Can I actually show this? How do I show this here? This slide that I just uploaded. Oh, there it is. Okay, great. And I think we want to go to like slide here. Perfect. Okay, great. This is fantastic. Okay, not slide 1. Here it is. Not that one either. Okay, hold on. Stop advancing. Oh no, I have a thing on API. Okay, hold on. We'll just zip through it. Okay. So open source software. So what I realized was that there is a commoditization and an innovation dynamic in open source. So classic infrastructure open source tends to solve these well-known problems. And actually, this is a criticism from the Microsoft folks in that early or late 90s timeframe. They're fighting open source and all the Slashdot nerds. And they said, you know what? Open source can solve well-known problems, but when you need new innovation stuff, you really need a bunch of nerds inside the four walls of a building being paid very well to go and think really hard about solving problems. And what I realized was, no, actually, open source was able to very efficiently plumb into and explore the art of the possible in innovation spaces. So it directly opposes that point. But in both cases, the way that it works, at both the catching the commoditization of well-known problems, as well as innovation, in both places, it's a marketplace dynamic, right? That you can trade off against how much do you want to be stable? To your point about the Python 2 versus Python 3 stuff, how much did people value stability in Python 2? How much do people want to go and lean into what was coming and be early in setting like what comes next? And the great thing about an open source ecosystem is people could choose. You chose to just nope out on the whole ecosystem. But some people said, we're going to stay with Python 2. And others said, we're going to stay with Python 3. But by using Python, they were all part of an ecosystem that gave people that choice to make that trade-off for themselves. This is hugely important, because one of the big selling motions for a lot of legacy enterprise software vendors is the EOL move to say, oh, you know what? That's no longer supported. You're going to have to upgrade. It's a forced upgrade. And we had an executive that joined us, this guy. Yeah, this guy. Anyway, he was like, oh, you know what I realized about open source? You can't do forced upgrades. I'm like, no shit, Sherlock. Like, hello. But that's how people steeped in that kind of proprietary extractive world have that point of view. So what happened is the PyData and the SciPy ecosystem for 20 years successfully pursued the art of the possible, but they did in a particular way because it was people who are not trying to make the next great end-all be-all software. It was not people trying to build something and get users to go raise money from Silicon Valley, right, from Sand Hill Road. These are people just need to solve their problems. They're researchers at CERN, they're astrophysicists, they're geneticists, they're researchers at Caltech, right? So they tended to limit the scope of what they were doing. They tended to look around, see who else is doing something cool I could use. There was an approach, the DNA of the ecosystem, the DNA of the human ecosystem around this gave rise to a cellular and modular approach to innovation. You would reuse what you could, and if you couldn't, you would build your own variant. And then if enough people needed both of these things, you would sort of smush them together. And a little bit of maybe now forgotten history is that my co-founder, Travis, who created NumPy, he created NumPy as the synthesis of two projects that had diverged. So in the late 90s, Python had one sort of matrix object to do numerical math, and that was called numeric. And then some folks at the Space Telescope Science Institute, they said, well, we want to do things a slightly different way. We have image processing, we have other algorithms, and we want to, they did this other thing called NumArray. So numeric and NumArray, by the 2004 timeframe, they were causing kind of a fork in the ecosystem because the array object is something foundational to numerical computing. And so Travis said, you know what, I'm going to have to bring these together. And he took a year out of his life to go basically come up with this core underlying system that was a matrix object, an array library that could dynamically expand the types, that could have basically primitives for doing broadcasting and all this kind of stuff. You call it a library, but I call it a protocol, right? Because what ended up happening with that is he built the high-level array object that Python people can use, but he also built underneath it the compatibility layers and the protocol for how you do C extensions and Fortran extensions that would then have views of memory that would plug right into the NumPy stuff. So you didn't have to copy gigabytes of memory back and forth. Okay. So he built a unifying protocol as a result of the ecosystem dynamic that emerged from this. No one was trying to megalomaniacally eat the world. They were just trying to solve their own freaking problem in the moment. And that led to this kind of humble scoping that led to the growth of an ecosystem, which then when it needed to could compress and synthesize and create some shared protocols. So if you look at what business valued open source, it's very different than what the open source community values, right? But the really important thing is they both miss a really important thing. And this is the thing you just talked about, which is that software isn't code. Software is the artifact that emerges at the intersection of users who have certain needs and an ecosystem, a maintainer base, a user and maintainer base that answers questions on Stack Overflow, all of that. It's really a human ecology that produces software that sort of like poops out code as a release object, right? And the difference is the difference between like the Mississippi River as a concept versus a scoop of water from the Mississippi River, right? You cannot say that scoop of water is not water from the Mississippi, but it's also not the Mississippi River. It's just a cup of water that happened to come from the Mississippi River. But the river as a concept, as an organizing principle, as a coherent, actually semi-stable pattern that winds its way across the landscape, that thing is actually the river, not any particular piece of water that comes out of it.
Let's extend that metaphor, and we have 7 minutes, so let's try to do this.
Right.
3 minutes so we can have or 5 minutes, let's say, and we leave a couple of minutes for questions. Okay, so you to extend your water metaphor, we could say like big corporate forced upgrade hydro ecosystems are more like dams that have been water has been locked away. You've got these open source ecosystems that are like big flowing rivers, and occasionally you can take like a cup of water out of them, right? And now we're talking protocols and AI together, which is a big theme for us this year. So the protocols thing, I think one interesting experience in the blockchain world is you do now have a repeat of the forced upgrade phenomena, but this for an organic source, right? You've got a network of nodes where if the nodes are not running the same version of the software, bad things can happen. So now you have like forced upgrades from like an ecosystem perspective. It's like, you have to vaccinate all node software against this new problem, otherwise the P2P network will fail. So we are recovering some of those dynamics in complex protocol driven ecosystems. And yeah, maybe you could spend a minute or two talking about your experience with Blue Sky and its ecosystem, and also how you see AI fitting into it. Like, this is the future we are heading towards, things like Blue Sky and blockchains plus AI being injected into that ecosystem that's now fundamentally a set of nodes that are getting upgraded in loose lockstep, right? So what is this?
So yes, so what I would say is that the reason why viewing every software API as essentially protocol, the reason why open source human ecologies that yield those kinds of software protocols and APIs, the reason why those are successful is because they still preserve, there's a point of demarcation between when the author is able to encapsulate their vision, ideas, and values, and they deliver it to you, and then you as the user, the recipient of it, you could also be a coder yourself, but you then can add your values to it. And there's a concept that boundaries are loving. There's a boundary there, and they love this space enough to give you this thing, but they love you enough to give you the right to do what you want with it, okay? This is really, really important. Because Facebook is also a protocol, right? The API between the JavaScript that runs Facebook when you run in your browser to the backend, that's a protocol. But one person gets to impose their values down that protocol. And what my concern with a lot of people who are blockchain nerds, and I say that with all the love in the world, because I'm also a blockchain nerd, right? But we end up with we can easily end up with a kind of technocratic megalomania to say, well, I can drive an upgrade across the whole thing. The question is, yeah, you can, but should you? Because if you do, that's going to cause people to opt out of this thing because they don't have a way to live their values, right? When we're in the middle of the Python 2 to Python 3 update conversations, and it was very divisive. It was very, very ugly fight within the ecosystem. A lot of really smart, well-intentioned people aiming towards the same North Star wanted to go in two completely different directions. And what I realized was that a lot of times the people pushing for certain things were not talking to the people who are using it. There would be big businesses who had massive multi-thousand person teams running and building and maintaining Python 2 code bases. They had 0 seats at the table for the people who are trying to push Python 3. And I could see that disconnect. I said, this is going to be a disaster unless some people start building these conversational bridges and those values can be shared. And that's in the best of cases. That's when the core Python Software Foundation folks and the steering council and like the BDFL, they all wanted to do the right thing. Now, when you go into the blockchain world, there are a lot of times when people have, less than overt economic incentives, when there are all sorts of things that cause them to use this kind of power. Are they really connected enough? Do they really know what all their users want enough to say, I've considered all of this. I have 1 million users. I see myself as like the feudal lord of a 1 million person realm, and I'm going to make the wisest possible choice. Is any person smart enough to make a wise choice for 1 million people and how they live their lives and certain kind of values? Well, if the answer is no, then what's going to happen? What's going to happen is they're going to take an instrumental view of the technology you've built. They're saying this technology is a complication that cannot actually receive all of the complexity in my context, in my world, in my life. I cannot impart my values onto it. And therefore, I will isolate it, leave it over there. You want a coffee maker that's on the blockchain? Great. It's only going to live in the kitchen making coffee for me, right? And so this is the kind of thing we have to be careful about when we talk about protocols and the power of protocols. That they're a really, really effective way to allow people to build in a modular way, to modularly effectively explore a possibility space. But if all this power is centralized, connected, it's very, very hard for me to say that there's that the power won't corrupt people, right? And this gets to the blue sky thing, where it's not really about decentralization. It's about creating a set of open protocols that many people can build apps on. Blue Sky is one app on top of the app protocol. My Sky Seed Fund, the entire founding thesis was to invest in things that are not Blue Sky, that are on this protocol, right? Like it's the early days of TCP/IP, and there's one killer app on it, which is, I don't know, SMTP maybe, right? And you send email. I'm going to invest in everything that's not SMTP. Right? I'm going to invest in things like Gopher. I'm going to invest in like FTP, things Telnet. So I think there's for me, that's the point of SkySeed, is to create a multi-stakeholder system on top of this protocol stack, so that people not only no single person is empowered to sort of make, be tempted to make these kinds of big decisions, but also ultimately we have an ecosystem and a viable human ecology where many kinds of values can be lived. And I think this idea of actually creating technical foundations for coherent pluralism, that's ultimately how we're going to get to real sort of the public intelligence kind of stuff. Like, I believe in all of that, but I think that if we come at it with a tech arcanum sort of ivory tower approach, to say the technologists will build these open protocols and you will like it and they will upgrade it on you when they tell you to, like, I don't think that's going to be the way that it moves forward. We have to find a way to encounter complexity, to give every person the sovereignty and the agency to encounter it in their own way, to put their values into it and to share and to evolve their values, and then bring that to a space that is able to think about not just the complexities, not just the complications, but also the complexities. And I think that philosophically, we don't have the underpinnings for that yet. And hopefully conversations like this and more beyond will at least start changing the conversation about what really needs to be done to have that that human vitality and that soulfulness in what comes next.
That's, I think, a great note to sort of end our portion of the conversation. And if you're able to stay 5 minutes, maybe we can take a couple of questions from the audience.
I'm wide open. Yep.
Okay. So, Timber, you want to come back online and maybe curate a couple of questions in?
Yeah, we do have a couple of questions. The first one is a definition question that got broken up into two, but I'll show the first part of it. Two-part question: definition of artificial, definition of intelligence. At what point does the threshold stop and you go from augmentation to artificial? If that makes sense.
Mm-hmm. Is this for me?
Anybody who wants to take it on. Peter, how about you go for it?
Okay. So yes, AI is unfortunately a very, very vague term and overused now. I think, yeah, okay. So artificial, I think actually I would really love if the conversation around AI and AGI really broke the different pieces apart, because there's many different pieces. There's the artificialness of it. there's the intelligence part of it. There's the general part of it. There's all of these things. Right. We don't have an agreed upon definition or unified theory of intelligence that we can apply even to organic life. Right. We know that cats and dogs are generally intelligent. I mean, a mouse is generally intelligent in many ways relative to its domain. I mean, it can't, write down calculus equations, but it can do fairly intelligent things. So we don't have a scalable and portable and general definition of intelligence, and therefore applying that to AI is an aspirational thing at best. But the A in AI, for me, is that right now we have a human-generated intelligence mechanism, and that's called having sex. So we are able to produce new humans that have intelligence. We also, I guess, animal husbandry as well. We can breed animals that are generally intelligent, and you end up with a generally intelligent creature. That's the only way that we know to generate intelligence. And intelligence loosely being something that is able to process a wide array of inputs and then take actions in a coherent way to achieve some goal or to manifest certain values or to live within some metastable zone in response to those outside things. Okay, so there's a general kind of what is intelligence versus merely stimulus response, like that Far Side comic from so many years ago. Intelligence, as we think about it from a maybe slightly anthropocentric and egocentric point of view, is this ability to process a large array of inputs and maintain some metastable sort of a hollow homeostasis around that. So in any case, the artificial part of this is that we can turn electricity into things that might have this kind of a mechanism to them. And I would much rather the world move to the term cybernetic away from AGI, because I think AGI is a bundling and a mess of all sorts of stuff. So anyway, I don't know if that answers the question at all, but that's a great way to trigger me to rant about some stuff. So I appreciate it.
I think that was great. We've got one more, which is about a topic that came up earlier in the conversation about the shadow development or shadow IT.
Shadow IT, yep.
Shadow IT. Do the richest solutions come not from the trenches, but from the frayed edges of liminal spaces? How does a generalist journey get shaped by an ethos of curiosity?
This is great. I'm curious. As a Warcraft guy, I see MOP, and I think Mists of Pandaria. But anyway, I'm going to sort of block that out with my finger. So we here in the West, I don't know if you're familiar with the frontier thesis, right? And this idea that what made America America, part of what the American character, what shaped the American character, is the European and Puritan Christian sort of approaches interfacing interfacing, I use that term fairly clinically, but in their encounters with the Native Americans and with the space afforded by the American wilds. Every square centimeter of Europe has been fought over for centuries. They come over here and there's a bunch of somewhat friendly, sometimes hostile Native Americans, but there's a lot of land. They just expand into it. And what happens when the mind, the heart, the culture, the civilization can expand into that space? There is a capacity, unless you're a complete robot, there's a capacity for complexity in this, right? There's a capacity to receive the awesomeness of nature and all of the stuff that the universe has to offer. You sort of commune with that. And so the mythopoetic architecture in America knows about this. It knows about this. And it sort of, we know we go out there to recover something, to find ourselves. We know we go out there to figure out what's out there, whether it's Hunger Games, whether it's, anything pretty much. You'll find people doing this kind of a journey, this walkabout, right? Where does Luke go to find Kenobi? He has to go out, right? He has to leave kind of where he is. Where does Harry Seldon go? He goes to the edges of the empire, right? There's nothing left in the city. It is completely colonized. It's KPI'd and OKR to death. And it's basically just a Gervais stack of a bunch of sociopaths governing a bunch of clueless people that then run terror over and have a reign of terror over the people at the very bottom of the stack. So I think this idea that we have to go and encounter the edges and encounter out there and bring it in, and our ability to do that without losing ourselves, but without turning it into just more of the same, without projecting our own, extending our own biases and perspectives out there and losing that signal. That is all of it. That is the entirety of that. Every cell has this struggle. Every sponge in the bottom of the ocean has this struggle. great article by God, what's his name? So on being the right size. One of the greatest science essays by Haldane on being the right size, and he talks about how all of life is trying to solve an r squared versus r cubed problem. That you encompass more and more volume, but your ability to move food and nutrients and exhale waste, it goes around a surface boundary that's r squared. And the shape of creatures and the shape of organisms and the shape of human ecologies, as we try to pump more and more things across a membrane while we try to reap the benefits of an enclosure that is relatively homogenized and that shares values and has a protocol stack where everything is the same. This is all of it. This is the whole theme of everything in life. This is the kernel. This is the fundamental kernel of what everything is. So when we talk about shadow IT and how do organizations and how do they, everyone wants to talk to me, because when I'm not philosophizing about this kind of crap, I'm actually, believe it or not, an actual IT executive, and I'm able to go and do talks at these kinds of places. I talk to IT people and see CIOs, CEOs who are like, how do we do digital transformation? How do we, make our organizations ready for the AI revolution? All this stuff. Actually, I have a webinar tomorrow about this. But the way that all of them are asking this question, they're managers. They have a managerial view of technology, and they don't understand that the only way for your organization to actually reach its full power in an AI world is to reinvent and transform the organization, to put soul back into it. You could be more mission aligned, more innovative. It's all the things that the board wants, but every single managerial CEO will never be able to do it because they are managing to OKRs and KPIs. At no point, if you're managing a caterpillar, at no point does the transformation to butterfly look like a good thing. Okay. Like you are literally losing coherence internally. You're not moving. You're gonna get eaten by shit. Why are you pooping out all this silk? What are you doing? You're a crappy caterpillar. Well, as you're transforming to becoming a butterfly, all the OKRs and KPIs fall off the side, right? So here, to answer this question about things coming in from the edges and whatnot, for us to maintain, for that caterpillar to be the same butterfly, there's some essential core of vitality, some core of what it is in the world that has to be preserved. Otherwise, it really did die. It just got eaten and it's being digested inside the belly of some creature that ate it, right? But if it's going to be a butterfly, there's some parts of the DNA that are the same. So when we talk about how IT organizations can transform, this is not another turn of the crank. This is a radical re-envisioning of how you radically empower all of the knowledge workers who actually understand the business problems, who are not sitting there just to click buttons on a bunch of SaaS software you procured, but you actually have to empower those people to do good work, to actually manifest the value. You as an organization have to impart the values into those people. You have to treat them as non-fungible cogs, right? Like there's all the stuff that has to be done as an organization. And then I think, and only then, can you fully actually take advantage of the potential of AI for a business.
Well, thank you for answering those questions, Peter, and thank you so much for your time and sharing these thoughts. I know that everybody who watched found it interesting, and we'll circulate it with the rest of our audience who is asynchronous. I'll take you guys off the stage and do my little closing spiel.
Thank you guys very much for having me.
Great to chat, Peter.
Thank you, everybody, for watching. The next talk is with the Summer of Protocols director, one of two, Venkatesh Rao, who will be talking next week, April 2nd, Wednesday at 7 p.m. Pacific time. And yeah, tune in to learn more about science fiction, what that means for protocols, what's going on at the frontier of protocols, what we have in store for 2025, and maybe some other fun topics. There's lots to talk about these days. So we'll see you next Wednesday.